Hello everyone, welcome back to another video. This is Pranav from Sri Venkateshwara College of Engineering, and in this video we'll be looking at the topic data preprocessing for machine learning projects. So to build any kind of machine learning model, firstly we need a proper data set, and the data set is to be preprocessed. And data preprocessing is one of the critical steps in machine learning that involves transforming the raw data into format that is suitable for analysis and modeling. So, in a machine learning workflow, data preprocessing can greatly impact the accuracy and efficiency of the model. And to and in data processing, there are certain techniques, and some of these techniques are data cleaning, data transformation, feature scaling, feature selection, and data splitting. Data cleaning refers to removing or correcting any kind of mistake or incomplete data present in the data set. This is to ensure that the data is accurate and reliable. And data transformation involves converting our data in from one format to another, such as changing categorical variables into numerical values. This helps us standardize the data and make it easier to work with. So basically, data transformation also involves segregating the data into one kind of format. In a classifier machine learning model, if we use certain type of images, that is JPEG and PNG, any other kind of format will be denied and will be deleted. Coming to feature scaling, this involves rescaling the features in the data set so that they are on the same scale, which can help improving the accuracy and efficiency of the machine learning model. Okay. Next one is feature scaling, that involves selecting the most relevant features in the data set, the machine learning model. Again, it depends on the model, and there are relevant features to each and every model, which help in reducing overfitting and improving the accuracy of the model. And data splitting refers to splitting the data into training, testing, and validation sets uh, that helps us gain knowledge of the performance of the model and also over the unseen data that is present. Overall, it is a really important step in our machine learning workflow. Rescaling data. So when a data is comprised of attributes with varying scales, multiple machine learning algorithms can benefit from rescaling the attributes to have all the data on the same scale. So this is useful for optimization algorithms used in core of machine learning algorithms such as gradient descent or softmax optimization and various other optimization techniques. It is also useful in algorithms such as that use weighted inputs like regression and neural networks, and algorithms that use distance measures like nearest neighbors, etc. So we can rescale the data using scikit-learn. So it is a module present and using the min-max scalar class in the module. So here we can see a small program to pre-process our data. Firstly, we are importing our pandas, that is by import pandas as PD. So from sklearn, that is our module, we import our standard scalar. By importing this, further we go and load our data set that is present in our system by using df, that is our data frame, is equals to pd dot read underscore csv. So this is the function in Python for reading the data or loading the data set. And our data.csv is uh, data.csv is loaded over here. Further, the next step is to remove any kind of missing or incomplete data. Again, we have seen this in the second step in our first slide. So df dot drop na in place equals to true implies we drop all the data that is not relevant to this kind of data set, and it filters the data. Further, we convert our categorical variables into numerical values using our encoding. And the next step is to scale our data using the standard scalar. We use scalar.fit transform data frame. And the final step is to split the data. That is using our last function, that is uh, training, testing, y train, y test. So we split our data into four types, that is two training and two testing models, and we scale our data. So feature scaling is one of the most important techniques as we discussed. So feature scaling is done to normalize the features in the data set into a finite range. So our data set might be present over a huge range, that could be infinite or could be very huge. So to scale the data and normalize it, it helps us predict the kind of outcomes, and also such a way that the model can process it without any problems. So in Python, as you can see, this is your unscaled data, and feature using feature scaling in Python. This is how your data set would look later. So in feature scaling, there are five techniques, that is absolute maximum scaling, min-max scaling, normalization, standardization, and robust scaling. The first one, absolute maximum scaling. So to find the absolute maximum value of the feature in data set, so we divide all the values in the column by the maximum value of the data set. So doing this, if we do this for all the numerical columns, then our values will lie between -1 and 1. So the only disadvantage with this technique is that it is sensitive to outliers. So as an example, you can see the third point. Further, in min-max scaling, that is the second technique, we'll subtract the minimum value in the dataset with all the values, and then divide this by the range of the dataset, that is maximum minus minimum. So in this case, our dataset will lie between 0 and 1, unlike the previous case where it lies between -1 and 1. Again, this technique is also prone to outliers, and this is the formula that stores the new values, that is our 0 to 1 values. And the third method, normalization. So instead of using the minimum value in the previous case, we use the mean value or average value of all the data. So this helps us uh, shaping or changing the data into a particular kind of distribution. So the fourth method is our standardization. In standardization, we calculate the z value for each of the data points and replace those with the values. So this makes sure that all the features are centered around the mean value with a standard deviation value of 1. So this is best to use if our features are normally distributed like salary or age. And once again, this is the formula that is being used to store our values, and this is the major formula. Further, coming to the last one, robust scaling. So in this method, we use the same formula, but instead of the standard deviation, we divide it by the interquartile range value. So interquartile range value is the distance between 25th percentile point and the 50th percentile point. So this method centers the median value at 0, and then this method is robust to outliers. So it overcomes all the disadvantages of our first three methods. And this is the formula that is used, or the Python code that is used to store. So techniques for handling missing data. Other than feature scaling, we can use a few other techniques in Python to work on our data set that makes it more reliable and more accurate. So there are specific set of ways to handle the missing data and make the data complete. For example, we can see our first method, that is data removal. So we remove any kind of missing data that is present in the table. In the previous example, you can see the years of experience is missing in our employee, and the salary is missing in our junior manager. So the data is removed. Those two particular columns are removed. The second method is filling the missing value through statistical imputation. So we fill the values of the uh, missing locations using statistical imputation, and this is the relevant formula for it, or the program. So statistical imputation means we use our mean value of the data set to fill in those values. So coming to our third method, that is filling the missing value using observation. the user manually fills the missing data from observation. This may be possible sometimes for small data sets, such as within a range of 20 or 30 columns. But for larger data sets, it is very difficult to do so. So the user basically just fills in the data set that is more reliable or relevant. Coming to our fourth method, that is filling in the most repeated value. So the most repeated value in our data set, or the most nearest one, could be a good reason for it to do so. So this is done when most of the data is repeated and there is a good reasoning to do so. So if there are no repeated values, then we can fill in with any one of the numbers that is present in the respective column, and filling in with random value within the range of available data. So once again, this also comes in with certain kind of drawbacks. The data might not always be reliant, but it does work in certain cases when the data set is large. Thank you everyone for watching this video. I hope you liked the video. Please do like and subscribe the channel.